Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I am the teacher, Miss G, and for today's math topic, we're going to be looking at scatterplot graphs. Let's get started. All right, so a scatterplot graph, what is it? You're looking at one right now. This is a set of data placed on a coordinate plane, and we call it bivariate data. Let me get my PowerPoint to work here. There we go. Scatterplots are basically graphs that use points to display numerical data with two variables. We call that bivariate data. And so we have an x-axis down here, which in this case represents the number of items. That's one of the two pieces of data. And then we have the total spent. And that would be your y-axis. That's the other variable, the other part of the data. And then all of these little dots or points here on the coordinate plane are data points, basically. Oops. All right, now this basically is the scenario that we're looking at here. Cherie went to the mall and took a survey of some of the shoppers to see how many items they had purchased and the total amount of money they had spent. She put her survey data and created a scatterplot. I should have said she put her survey data on the scatterplot. Anyway, so how many data points does she have? How many people did she survey? Well, if you count, the different points here, like this first person here, he had one item and paid $40. This second person here got two items and paid $20. So if you follow each X value up to the point and then follow it over to the Y value, you'll see how many items they got and how much they paid. So yes, how many shoppers did Cherie survey? That would be 16, because if you count all of these dots, you're going to get 16. According to the data, though, if you're looking at it, do they have an effect on each other? Like, are you seeing a general trend? And we talk about the general trends in the data as associations, and we're going to go into that a little bit more on the next slide. But if you look at this data, you're seeing a positive association. So that means as the number of items go up, the total spent went up. And the reason why I know it's, let me get my pen out here. Oops, too far. Let me get my pen out here and I'll show you what I'm talking about here. So as the number of items goes up along the x-axis, the total items tend to go up. And I can see this because if you look at this trend in the data, you're seeing that it's kind of looking like a positive sloped line here. It's going from left to right up in general. Now, of course, there are exceptions that we're going to talk about. But at this point, if you're looking at it, this is what we call a positive association, when it looks like the data is going from left to right, pointing upwards. And that's how you know that as the x-axis variable goes up, the y variable is also going up. Similarly, in this same graph, if I bought less items, I'm probably going to spend less money. So when it's a positive association, both variables are either going up or both variables are going down together. Okay. Now here are some associations. Another word for this associations between scatterplot data is called correlations. You'll see these used interchangeably, but they do show the relationship between the x and the y axis, the two variables in the scenario. We talked about this one first, the positive association, the two variables that have a positive association when the variables move together. For example, as one variable increases, the other variable increases. Another example is when one variable decreases, the other variable decreases. So again, this is positive because if you're looking at this, general trend in the data, it looks like it's kind of going up from left to right. That's what we call positive association. The second one here is negative association. When two variables have a negative association, they move in opposite directions, the two variables, which means as one increases, the other one's decreasing. So if the x is increasing and the y is decreasing, or vice versa, you're going to get what looks like a negative association. Negative associations look like they're going down from left to right. We always read our graphs from left to right, just like reading a book. And then we have a third association here that we haven't talked about yet, and that's called the no association or no correlation, if you're using the correlation word instead of association word. That's when two variables have no association. Like, for instance, if I was comparing, does a cat, the amount of food a cat eats, is that associated with the color of my dog, right? There's no association there. So if you gathered data on that kind of stuff, you're not going to find an association. Like if you look at this graph, you can't really tell if it's going up or if it's going down. Like you can't tell from the data points. So because of that, there's no association. All right, now here are some different associations so you can kind of get a better idea of what we're talking about. If a straight line can be drawn to represent the general trend in the data, it's called linear. Okay, so if you're looking at this first graph here, I could literally draw like a straight line here, and it kind of represents most of that data. That would be a linear association. If the points are close together, the association is strong. And if the points are widely spread out, the association is weak. So if I'm trying to answer this one, I'm saying, okay, this is a positive because it looks like it's going up from left to right. It's strong because the points are kind of close together. They're not very spread out. Okay. And it's also linear. So that's what we have here. Now, on the second one, it looks like this one's more of a weak positive. It's still going from left to right up. Okay. But the points aren't as close together. And also, it's still linear. This third one here is also a positively sloped going from left to right up. But if you notice, it's actually curving like this. And because it's curving and not necessarily going straight like the line I wrote above it, we can't call this one linear. So I would say this one's pretty strong. Let me erase my first line so you can kind of see the graph better. I would say this one's strong, but it's not linear, and it's definitely a positive association there. Now this one is going from left to right down. The data points look very close together in my opinion, and you can draw a straight line that represents the trend in the data. That would be a strong negative, and it's linear. This next one here, it looks kind of weaker, and it does curve a little bit. So I would say this one's not linear because of that curve in the data. But it's definitely negative, and I would say it's kind of weak. So weak, negative, nonlinear association there. And then of course, this one that we can't tell if it's going up, down, or whatever, we're going to say this one's no association. And no associations are never linear, and they're never, and you can't really tell if they're weak or strong because there's no association there. All right, now here are some circumstances where we have to determine the association based on the words of the scenario, right? So without even looking at the graph, can you tell what this association would be? The first variable, a person's height. The second variable, a person's shoe size. So what you have to ask yourself when you're doing this kind of thing is, if a person's height increases, would the person's shoe size in general also increase? And if the answer is yes, then we know it's a positive association. Okay. The number of letters in a person's name, if those increase, does that mean that their IQ is going to increase? That's intelligence quota, by the way. So does a person become more intelligent when they have more letters in their name? I would say no. I would say that's not really related to each other, and that would be a no association circumstance there. The third one is a number of absences that a student has and the student's grade point average or GPA. So if the student has more absences, in general, the student's grade point average goes down, not up. Okay, now we're not talking about everybody. We're just talking about in general, the general trend. And there's a lot of data to show that when kids miss school, their grades tend to go down a little bit. So I would say since one is going up and one is going down, that is a negative association. So we have positive, no association, and negative association. Both of them went up in the positive. Both of them increased. Both of them, there was no association here because you couldn't tell if that was going to go up or down based on the person's name, the letters in their name. And then this one went up, one increased, and one decreased. And anytime one of them increases and one of them decreases, that is a negative association. All right, now we're going to interpret these scatter plots here. The first one is, we're just going to say, what's the relationship? And the first thing I wanted to point out too is the outlier. Okay, so right here, as you can see, we have a point that doesn't really look like it fits with the other points here. And that's what we call an outlier. Okay, so an outlier is a value in the data set that lies outside the overall trend. So if something doesn't look like it fits with the other data, it's called an outlier. And that sometimes happens when you're taking data, when you're, doing a survey or something like that. You might get a general idea of the responses being the same for a lot of people, and then you'll have like one weird person come up and say something really totally different. And so that's what we're talking about, outliers. Okay, so if you look at this one, it looks like it's a positive trend. So it's going up from left to right. And because of that, we know that as the growth as the days increase, the pumpkin weight in pounds is also going to increase. Okay, so that's what they're talking about. What is the relationship between the two variables? Well, what are the two variables? It's your X axis variable, and then it's your Y axis variable, right? So you're basically comparing your X with your Y. And so I know because it's positive, as one goes up or increases, the other one is also going to go up. And it makes sense because pumpkins grow and get bigger and over time, right? So it does make sense. The second graph that we have is comparing a car age in years with the cost, with the value of that car. And once again, we have another outlier here. I'm just going to circle it because it doesn't look like it fits with most of this data. It does look like there is a negative trend because from left to right, it looks like it's going down, which means that as the car ages, gets older, the value is going to decrease. And those of you who have ever talked to someone who's bought a car, that actually does happen when you buy a car. The very next year, your value is not the same on that car. It'll be lower. Now there is a point once the car gets really, 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 really old, if it becomes considered a classic car, like a collector's item kind of thing, the value could go back up eventually. But most of the time, the values are going to go down after you buy the car over time. Okay, so that's the relationship between those two. And I think there's a third one. Yep, here's the third one. Okay, now we have, is that the same one I already did? Oh, this is the same one I already did. Okay, so we didn't have a third one. Okay, but now you get an idea of what about the relationship between the 2 points. All right, great job, y'all. So remember that we can create scatter plot graphs to show general trends and associations between the two variables. We call that bivariate data when there's two variables that we're comparing. Remember that if both the X and Y variables are moving up or down together, then that's going to show a positive association, which means that the trend will look like it's going up from left to right. Remember that if one of the variables is increasing or going up, while the other variable is decreasing or going down, it will show a negative association, which is going down from left to right on the graph. Remember that if the data doesn't show a trend going up or down when you read it from left to right, there is no association. And remember that the closer the data points are together, the stronger that association is. Remember also to avoid outliers when looking at general trends in the data. So that is basically an introduction into our, why is my mouse not working? Into our unit on scatter plots. So the next video you should watch is called Scatter Plots and Lines of Best Fit. And we're going to show you how to do more with these scatter plot graphs. And also I will show you on Desmos how to plot a scatter plot graph from a table of values, and also how to draw a line of best fit through that data using Desmos. So now it's time for me to say it was lovely teaching you math today. We'll see you next time. Bye.